All right, welcome back. We made it. I'm going to run through section 8.4 real quick, which is multiplying and dividing rational expressions. At this point, we kind of, again, go away from graphing, and now we're just going to do some straight up algebra with this stuff. Our EQ is what are rational expressions, and how can I multiply or divide them? So to start, we're going to do a little bit of factoring real quick. Again, factoring is going to be a huge part of the rest of this chapter. So here, if I've got a standard trinomial x squared plus 5x minus 50. No GCF, nothing that I can take out all three terms. So I'm just going to go ahead and find factors of C, which is negative 50, that add up to B, which is 5. In this case, I see 10 times negative 5 equals negative 50, and they add up to positive 5. So my factors are x plus 10 and x minus 5. That one's done. Okay. This is, again, a very common factoring problem to see, something like x squared minus 36. Again, no GCF, nothing that I can take out of both terms. This is what we call a difference of squares, which means that if I recognize I can square root both of those and it's subtraction, that means that I can factor this into two conjugate expressions. Conjugate just meaning that one has a plus and one has a minus. And of course, this is going to be x plus 6 times x minus 6. So that's how that second binomial factors. It's binomial because it's only two terms. And then finally here we have 4x squared minus 16x plus 12. Here I do have a GCF of 4, so I'm going to go ahead and take that 4 out. Anytime we can make these numbers a little bit smaller and more manageable would be a good thing. Now I'm going to factor what's in the parentheses. I notice that I no longer have a number in front of x squared, so I'm just going to go over here and find factors of 3 that add to negative 4. That is negative 3 and negative 1. So here I have x minus 3 times x minus 1. And don't forget to bring that GCF out front. So this would be my final result. Oopsies. So again, factoring going to be a pretty big chunk of the rest of chapter 8. So just to put a definition to this real quick, a rational expression is simply a quotient of polynomials. Quotient meaning, this is fancy math talk. A rational expression just means it's a fraction. And in this case, most of the time fractions will have the same variable in both the top and the bottom. So here's an example of a rational expression. Okay, x minus 1 on top, x plus 1 on bottom. Something that this is a common mistake that students make is, they think that these x's can cancel out. And then they see negative 1 divided by positive 1, and they say, well, that must just equal negative 1. What we've been seeing with the graphing is that in order to cancel an expression, you would have to cancel the entire factor. So in this case, x minus 1 is one entity, and so is x plus 1, a separate entity. They are not identical, so nothing cancels with that. Is a rational expression, but could not be simplified. On the other hand, here we have a rational expression that is already factored, 3 times the quantity x minus 3 over x minus 3. I can put parentheses around that x minus 3 to clearly see that those would cancel, and this would just simplify to be 3. So what we're going to be getting into today is when can I simplify a rational expression, and how do I multiply rational expressions together? Okay, so the first thing we're going to do is just simplify this thing. Okay, so simplify each rational expression, and then determine the domain. In the book, they also refer to domain as restrictions on the variable. So also going to use that terminology. So if I look at this first rational expression, I have 24x to the third y to the second over negative 6x squared y cubed. I see 24 over negative 6, and I know that that is negative 4. So I'm going to put negative 4 over 1. The 1's not really necessary. And then I've got x on both top and bottom. Now, before I start canceling things out, we do have to talk about the restrictions. Okay. I see both x and y down here. Neither one of them have any addition or subtraction. So basically my restrictions are x can't be 0 and neither can y. Because if either one of those is 0, I'll be dividing by 0. You have to do the restrictions before you start canceling. Okay, this step right here has got to occur first. Discuss this, and then we'll go back and simplify this and write it a little bit nicer. Okay, so I see I have x on both the top and the bottom. I've got x to the third over x to the second. These two x's on bottom will cancel out 2 of the x's on top, changing this down to just x to the first. And then the same thing happens with the y's, except the 2 y's on top will cancel 2 of the y's on bottom. So what I end up with is a single x to the first power on top and a single y to the first power on bottom. This is our final answer. Some of you will probably not want to put all those ones in there, and you can write it just like this. Also perfectly acceptable. Just like that. Okay. So this is our final answer that we're looking for, again, with the restrictions that x or y cannot be 0. Even though x is no longer in the denominator, we have to talk from the very beginning. Here, if it's not factored, we're going to factor it first, just like we did when we were graphing. This is actually supposed to be x squared plus 7x plus 10. That's my bad. This is x plus 5 times x plus 2. And on bottom we have x minus 5 times x plus 2 is how that one factors. Again, factor first, then talk restrictions, aka domain. So I see that x cannot equal 5 or -2 because those would give me 0 in the denominator. I can cancel out x plus 2 and x plus 2, right, which we learned would be a hole in the graph. We're not graphing this, we're just simplifying. So my final answer would be x plus 5 over x minus 5. Okay. And that is that simplification. So factor, restrictions, and then cancel stuff out if you can. Go ahead and pause this one. The second problem is something pretty important happens there, so hopefully you try it or at least watch what happens with the numerator of that second problem. Here I'm going to factor the top, so I got x plus 4 times x minus 2. And then on bottom I have x minus 3 and x minus 2. Again, we'll talk restrictions right away. So x can't be 3 or 2. I do see that I have a duplicate here, so x minus 2 is going to cross out or cancel out. And I'm left with x plus 4 over x minus 3 with these as restrictions. Okay. This second one, this is something that math people like to kind of be tricky on. You'll notice that the numerator is 12 minus 4x, and that's actually in the wrong order of what we're used to. We're used to seeing x first, and then our constant, or the number without the variable, is second. So I'm actually going to rewrite this as negative 4x plus 12 over x squared minus 9. That's what's called standard form, just to go variables first and then constants or numbers without variables. And the reason I'm going to do this is if I factor the bottom, I got x plus 3 times x minus 3. That's my denominator. If you look to factor this, okay, your first thought might be that I can take out 4 because that is a GCF. If I do that, I see that I get, if I take out 4, I end up with negative x plus 3. And while these might look real close, because they are real close, they cannot cancel out because they aren't identical. So what I need to do instead is actually, when I factor, and this is why it's important, we know that anytime the front term is negative, we need to include that with the GCF. That was aggressive. So if I factor out negative 4 now, I end up with x minus 3 remaining from my original numerator, which is awesome because now I see that this will be able to cancel out. I'm going to go ahead and discuss the Domain restrictions, x can't be -3 or +3. Of course, I do see that these do cancel, and I end up with -4 over x plus 3. There's my end result there. Okay, so again, simplifying, factor, talk about the domain, and cancel anything out that you can. When it comes to multiplying rational expressions, we're just all we're doing is multiplying fractions, and so in order to multiply fractions, really all we need to do is multiply the tops together and multiply the bottoms. I'm actually not going to like FOIL this. I'm just going to factor it and leave it as a bunch of parentheses. So you'll see what that looks like in just a second. So the first thing I have to do for all this stuff, I'm going to factor right away. So the top is of the left fraction is x plus 3 times x minus 2. The bottom is just x minus 5, so that doesn't factor. I'm going to throw parentheses around it just so I know that it is grouped together. Here, I have x squared minus 25. Again, just like the warm-up, that's that difference of squares. So that's going to factor to x plus 5 and x minus 5. And then on the bottom, I have x squared plus 4x plus 3, which is 3 and 1. Okay. Just like with simplifying, I got to talk domain restrictions right away, and that includes both fractions. So now I have three factors that I have to take a look at. So x cannot be +5, -3, or -1. Okay. Now, I could write this as one giant fraction with all 4 factors in the numerator and all 3 factors in the denominator. When it comes to cancellation or like crossing things out, as long as it shows up when we're multiplying, as long as the same factor shows up in the top and the bottom somewhere, I can cancel it out, meaning this x minus 5 can actually cancel that x minus 5, even though they're not directly stacked over one another. One is in the numerator, one's in the denominator, so I can do that because this is multiplication. Okay, so today multiplication and division is actually a little bit easier, allows you to cancel more stuff. So here I got the x plus 3s that are gone, and that's it for canceling. So again, I'm not going to actually multiply this out. I'm going to leave the answer factored because most of the time having factored is easier than not having factored. So this is my final answer. X minus 2 times x plus 5 all over x plus 1. Hooray, we did it. Yep. Okay. So go ahead and give this problem a shot, factor it, simplify it. Here I got 2 times x minus 4 over, again, that's that difference of squares, not squared, x plus 4 times x minus 4. I see I already have some cancellation, but I need to talk domain before I do that. That's x plus 4 and x plus 1. And then here is x plus 4 and x plus 4. This brings up an interesting point. You'll notice that the denominators are just a bunch of 4s. So my restrictions are x cannot be +4 or -4. Okay. And this is, I think a couple people have brought this up. I can cancel this x minus 4 with that x minus 4. And even though the bottom has 3 x plus 4s, I can't I can't cancel multiple of them out on the bottom. So like this x plus 4 will cancel another x plus 4, but only one of them. So I'm left with 2 on the bottom. So again, not gonna redistribute. I'm just gonna write it like this over. Now, since it is 2 different x plus 4s, I'm gonna go ahead and shortcut it and say it's squared, because we know that squaring something just means multiplying by the same thing twice. So there's our final result. Again, domain restrictions being up here. Okay. Looks good. Okay. Now, that was multiplying. If it's division, it's actually it's very similar. The difference is I need to, well, first let's factor this, and then we'll get into all that. Again, this is one of those sneaky ones, the 2 minus x. I'm going to take out negative, I'm going to rewrite it as negative x plus 2, which then, okay, I'm just going to do this on the side. Oh, boy. So this is negative x plus 2, which means I'm going to factor out negative 1, and then this becomes x minus 2. So that's my numerator. Okay? Anytime you see the x after the number, switch them around, and then if it's a negative, take it out as part of the GCF. X squared plus 2x plus 1 is going to factor into x plus 1 and another x plus 1. X plus 1. I could put squared here. I like to keep them separate for now, just so I can visually see that there are two of them. That top factors into x plus 5 and x minus 2. And then the bottom factors into x plus 1 and x minus 1. Again, difference of squares. You will see it. Be ready for it. Okay, so I'm going to talk about domain now right away. X cannot equal negative 1 or positive 1. That's all I have currently. Now, when we talk about dividing fractions, when you learned to divide fractions, you actually take the second fraction and take the reciprocal of it. So you're going to flip it on its head. And that changes the division problem into multiplication. So it's pretty similar to what we did in the last couple slides. So I'm going to keep this first fraction the same. The second fraction, I'm going to just wholesale switch everything around. Okay. So this, notice that the division becomes multiplication as long as I flip what comes after that symbol. So the x plus 1 times the x minus 1 is now on top, and the x plus 5 and the x minus 2 are on bottom. Now this is where I have to be careful because now I have a new denominator. So I actually have to add to my list of numbers that are not acceptable in the domain because two new numbers have added themselves to the list now. X also can't be negative 5 or positive 2. So I'm going to add those to this list up here. So this as you're going through these problems, keep track of what's in the denominator and what x can't be at every stage, every level. And now I'm just going to cancel what I can. So what do we got? X plus 1 with x plus 1. X minus 2 goes with x minus 2. And then all that stuff is what's left. So I got negative 1 times x minus 1 divided by x plus 1 times x plus 5. Okay. Again, domain restrictions back up at the top. So multiplication, factor, cancel, division, flip it, factor, cancel. And that is about it. So I'm going to cut this off here. There is your homework. It's page 531, 9 to 27 odd, 33 and 49. See you later.